Assalamualaikum and hi everyone. So our group will present about graph theory. So I will introduce myself first. My name is Muhammad Adam Haris bin Muhammad Zaidi. My metric number is 230380. So first we move to a graph model. So the intro is the graph is proven to be extremely useful tools for analyzing situation involving a set of elements in which various pairs of elements are related by some property. The graph contains vertices or nodes and edges. So there are several types of graph models. First is undirected graph, or the simple graph with no arrow and direct in edges. Next, we have directed graph, which have the arrow at the edge to represent the direction. And third, we have weighted graph, which is each edges have weights representing the strength or cost of relationship. Fourth, we have the multiple graph, where it allows multiple edges between the same pair of nodes. And lastly, we have bipartite graph, which is nodes are divided into two distinct sets, and edges only connect nodes from different sets. Next, we move to the application of graph models. So the graph used to be model for social network, communication networks, information networks, software design, transportation network, biological network, and so on. So I will pass to my friend.
For me, I'm going to explain about the isomorphism. The definition of isomorphism is two graphs G1 and G2 are isomorphic if they exist a one-to-one function from V1 to V2. If two vertices U where U is a subset of V1 are connected by an edge in first graph, then their image FU and FV are connected by an edges in second graph. And for the condition for isomorphism, they need to have a same number of vertices and edges. And the important part is the degree of each vertex in first graph must match the second graph. For example, if first graph have vertex A and the degree is 2, so it need to correspond to a second graph where the vertex have a degree of 2. In determining whether these two graph is isomorphism, the graph of isomorphism is quite challenging due to n factorial, where n correspond to the number of vertices. The best algorithm for graph isomorphism have exponential worst case complexity, depends on the number of vertices. And graph invariant are property preserved under isomorphism that can help show graph are not isomorphic. And they actually have a step to determine if the graph is isomorphism. Step number 1 is both graphs have same number of vertices and edges. Second, compare the degree of each vertex. Each vertex in one graph must have the same number of degree as it corresponds to second graph. Just like I said, when vertex A must have correspond to graph B, second graph, and the vertex must have the same degree. And third, match the vertices of both graphs and make sure that connected vertices in the first graph are also connected in the second. Lastly, check the edges between the vertices matched in both graphs. in application of isomorphism, there is actually a lot of we can use in our real life. One of it is a molecule graph represent atom as vertices and bond and edges. This allows scientists to compare whether the two molecule, if they are same compound or not. Second, they also can be used in electronic circuit are modeled as graph, where vertices represent component and edges represent the connection. With graph isomorphism used to verify design and check for intellectual property violation. And then for edge counting, we can use a handshake theorem. For the explanation, in any graph of G where the vertices are labeled as V1, V2, V3 and so on until Vn, where n is the non-negative number. The sum of the degree for all vertices is equal to twice the number of edges in the graph. This can be expressed as a sum of degree equals 2 times number of edges. Since each of edges in the graph contribute to the degree of two vertices, the sum of the degree will always be an even number. Therefore, the sum of the degree for all vertices in any graph will always be even. And for application of edge counting, graph density calculation. It helps how connected graph is by comparing actual edges to the maximum possible edges. Second, for network analysis, make a map for a connection of network like transportation, social network and communication. This can help for people to make a graph that can understand more easily and readable. Thirdly, social network determine the relationship between individual by comparing for if this person have a connection for the next person and so on.
Alright, next I'm going to explain to you about planar graph. Imagine that you take out the piece of paper and you start to draw a graph. Now maybe the graph you draw looks something like this. You'll notice the two edges cross over each other and we call that an edge crossing. But we could draw the exact same graph in a different way with no edge crossing. Thus, this leads us into two definitions, which is planar graph is a graph that can be drawn on a plane without any edge crossing, while for plane graph is a planar graph that has been drawn in such a way that no edges cross each other. For the region in the graph, every plane graph has an unbound region called the exterior region. For example, of non-planar K33 is one of them. This is because there always be an edge crossing. Next, about the Euler's graph theorem. For formula which is V minus E plus R equal to 2, which V stands for number of vertices, E for number of edges, and R number of region. You can see the example on the right side. Alright, next I'm going to explain about proof of Euler's summation by induction. Here we can see that n plus 1 case, which assume that Rn equal to En minus Vn plus 2 is true. And Gn represent the previous graph and Gn plus 1 represent the new graph that we get. So for case 1, we see that our new graph, here we can see the region, the number of region is increased, R1 and R2, and also there's this new edge in the middle here. So we just assume that Rn plus 1, which is the new graph, equal to Rn plus 1, indicates that the number of region is increased. For edges, the number of edges is also increased. So we just repeat the same thing. While for the number of vertices, it remains the same. Thus we get this. Just apply it to the formula. And the negative one here and here cancel each other out, and we get Rn plus 1 equal to En plus 1 minus Vn plus 1 and plus 2. Thus we get the same thing, the same formula from above here. Then for case 2, we see here the number of edges increase, but the number of region remain the same, but the number of vertices increase by 1. So we just repeat the same thing. Rn plus 1 equal to Rn because there's number of region remain the same. En plus 1 equal to En plus 1. Number of edges increase, number of edge increase. Vn plus 1 equal to Vn plus 1 because number of vertices increase by 1. So just apply it to the formula, which is Rn plus 1 equal to bracket Vn plus 1 minus 1. Vn plus 1 minus 1 and plus 2. Thus negative here and here we cancel each other out. We get Rn plus 1 equal to En plus 1 minus Vn plus 1 plus 2. Thus we get the formula back, same right here. Next, for the region degree, we follow this convention. The inner region, which is blue, has degree 4, while the outer region, red, has degree 6. For example, on the right side, R1 has 3 degree, while R2 has 5 degree. Move on to the elementary subdivision. It is the operation which a graph are obtained by removing an edge. UV and adding the vertex W and the edge UWV. You can see the example at the bottom. For the last slide, which is the definition of homeomorphic graph, which means two graphs are said to be homeomorphic if one graph can be obtained from the other by insertion of vertex of degree into its edges. For example, G1 and G2 is homeomorphic with G3. Lastly, Krotowski's theorem, which means a graph is non-planar if and only if it contains a subgraph homeomorphic to K33 and or K5, such the given example you can see on the bottom.